Hello and welcome to this video on ether synthesis. My name is Ochem, and in this video we'll be reviewing the cleavage of straight chain ethers. Both high temperature and a strong acid is required to break up an ether, and if you think about the structure, it makes sense. An ether is an oxygen surrounded by two alkyl groups, and while the oxygen is more electron negative than the surrounding carbons, the oxygen is drawing electron density away from two sources, not just one. Therefore, the carbons attached to the oxygen are just not as susceptible to attack as you would with, for an example, a carbonyl. Straight chain or acyclic ether cleavage proceeds by two mechanisms, SN1 or SN2. For SN1, I remember the important difference by crossing out the 1 in SN1, and that reminds me that the mechanism proceeds via a carbocation. That means there must be a leaving group that leaves to result in a positive charge on my molecule. Here, the strong acid in the reaction conditions provides a source of hydrogen ions, which will protonate the oxygen to give us a good leaving group, allowing for half of the ether group to break off to give us methanol. Then the nucleophilic bromine ion can attack the positively charged electrophilic carbon, resulting in tert butyl bromide. Therefore, the products of an SN1 reaction will be an alcohol and an alkyl halide. The clue to look for in an SN1 reaction will be the reactant. If we have the oxygen attached to a substituted carbon, like our tertiary carbon here, it will be able to support the formation of the carbocation. A primary carbon would proceed via our next mechanism, SN2. Like SN1, the first step in an SN2 reaction will be protonation of the oxygen in the ether. The 2 in the SN2 refers to the fact that both the reactant and the nucleophile are involved in simultaneous bond making and bond breaking steps. Protonation of the oxygen allows for more electron density to be pulled away from the carbon so that the nucleophilic bromide ion can attack. At the same time, the carbon-oxygen bond breaks, giving us our products 1-bromoethane and ethanol. In general, the products of an SN2 reactions are the same as an SN1. An alkyl halide and an alcohol. The clue for an SN2 reaction is again the reactant. Primary carbons on either side of the oxygen gives enough room for the nucleophile to attack the electrophilic carbon. Our apply question involves cleaving dipropyl ether, which is a straight chain ether, and adding in bromic acid and high temperatures. We're also told the reaction follows an SN2 mechanism. What will be the products from this reaction? First, let's draw out dipropyl ether. Next, we'll note that bromic acid will dissociate in solution to form hydrogen ions and bromide ions. The hydrogen ion will protonate in the first step, and the bromide ion will act as our nucleophile. The quick and easy way to predict the products is to remember that both SN1 and SN2 reactions will give you the same products, an alkyl halide and an alcohol, using the alkyl groups on either side of the oxygen. Dipropyl ether will produce propanol and 1-bromopropane as products. For completion's sake, let's draw out the mechanism. First, we get protonation of the oxygen. Next, electron density is pulled from the carbon, allowing the simultaneous attack of the bromine on the carbon and the movement of electrons onto the oxygen, giving us our products propanol and 1-bromopropane. So, to recap, acyclic or straight chain ethers proceed by acid-catalyzed SN1 or SN2 reactions, and the mechanism will depend on the reactant type. The products of the cleavage will be an alkyl halide and an alcohol. With practice, you too can predict the products when an ether is cleaved.